Okay, the last thing we're going to look at in this chapter is trigonometric proof. And the first thing we need to look at is the difference between an equation and an identity. We've been using equations, we've been using identities, but what is the actual difference? So if I start off with this equation on the left, if I wanted to solve this, I'll expand the right-hand side, take 2x from both sides, add 1 to both sides, and I get this, x equals 3. So that means when I input x equals 3 into both sides, I should get the same thing. Let's check. 3 times 3 minus 1 is going to be 8, and then 2 times 3 plus 1, 2 times 4 is going to be 8. So yeah, that works. So that will be the only value of x that will work for. If there was other values of x, I should have got them. If I do this equation here, so I'll sort out the right hand side, expand, and then if I combine like terms, so I'll get a 3x minus 1 on there. Now if I take 3x from both sides, get a 0, and if I add 1 to both sides, I'll get a 0. Well, I've lost my x value, and I'm no longer solving it. I got the same thing on both sides at this step. So this one is actually an identity. I need to add an extra line in here. So the left-hand side is identical to the right-hand side. Basically, I could have taken the right-hand side, worked with it like I did in this step, and shown that I ended up with the same as the left-hand side. So they're identical to each other, just originally they were written in a different way. So I'm going to be presented with a range of identities, and it'll be a proof where I've got to prove that one side is equal to the other. So I'll read what it says. When we are proving an identity, we choose one side, usually the most complicated, okay? It's easier to uncomplicate something, so simplify it, rather than make something simplified more complicated. Okay, so we choose one side and then we manipulate it until it looks like the other side. So it says prove that 1 minus tan theta sine theta cos theta is identical to cos squared theta. So using what it's just mentioned here, I want to start with the left hand side because that is something more complicated than the right hand side. So first thing I do, make sure you're writing this down step by step, is I say what the left-hand side is equal to. I'm going to drop the identity symbol for the time being. Just work with the equation symbol. So I've just stated what side I'm starting on. Now I'm going to manipulate this as much as I can, and I'm hoping to get to cos squared theta. I want to aim for that. So first thing I'm thinking of is that this is an identity. So tan theta is sine theta over cos theta. You can write it down at the side what we're using. So 1 minus sine theta over cos theta, and then it'll be sine theta cos theta in a bracket. Just put it in a bracket because it looks a bit complicated. Now if I times by this bracket, I'll have sine squared theta cos theta on the numerator over cos theta. And you can see I've got cancelling here. So cos theta on the numerator and the denominator will cancel. I could have even cancelled it up here and not had to times by it if you spotted it. So I'll be left with 1 minus sine squared theta over 1, which I'll just ignore. Now comparing, this is looking promising. You've spotted it because 1 minus sine squared theta equals cos squared theta. So I'm going to replace that with cos squared theta, and I'm just going to state that I've ended up at the right hand side. So that is one full proof, starting off at one side, manipulating it, and ended up at the other side. So I've proved that the left hand side is identical to the right hand side. Let's do another one. So it says prove that this is identical to 2 plus tan squared x. Again, looking at it, the most complicated side is the left hand side. So I'm just going to write it out first. Make sure you're not doing any transcription errors. And while I'm writing it out, I'm thinking about what I can be doing. Well, straight away I've got a bracket squared. So I'm going to think about expanding these. I'll do them over here. You can do them at the side. But I'm going to be doing that. And then I'll be doing the other one as well. So I'll get a cos squared x minus 2 lots of a cos squared x tan x. Sorry, not a cos squared x, a cos x tan x. And then plus tan squared x. If I do the other one, I'll have sine squared x plus 2 lots of a sine x and then plus 1. Right, so if I input these in here then, and I'm thinking about what I can do from here. I want a tan squared x. I've got a tan squared x here. I want a 2. I haven't currently got a 2. But I have got a sine squared x and a cos squared x. And even though they're not together, I can still use this identity. So those two are going to equal 1. You can write them together if you want, but I'm just going to put 1 there. Those will be replaced with 1. Then I'll write the rest. So I can see how I'm getting the 2 now. And I can use the other identity because I've got a tan x. Let's see if that's helpful. Sometimes with these proofs, you've just got to give things a go. Sometimes it looks worse before it gets better. So I'll put the 2 together, and then it'll be 2 cos x sine x over cos x plus tan squared x plus 2 sine x. Right, I'll be able to do some cancelling here. If you want to multiply out, you can do, but I'm going to be multiplying by a cos x and divided by a cos x, so those have cancelled. So it'll be 2 minus 2 times by sine x plus tan squared x plus 2 sine x. I'm getting close. If you've you've spotted it, I've got a positive 2 sine x and a negative 2 sine x that will cancel. And I've arrived at my right hand side. Okay, so that's another one for you. Let's do a couple more. So this one here, prove that cos to the power of 4 theta minus sine to the power of 4 theta divided by cos squared theta equals 1 minus tan squared theta. Again, I'm going to start with the left hand side. Now you might be thinking, right, I've got a cos squared theta, I could change that to 1 minus sine squared theta. I've got cos to the power of 4 theta, so you might be thinking about that, how that can link to a squared. If you're ever stuck, just like I say, give it a go, because there are times when us as teachers start off the proof and we find that actually what we started with, what we've attempted, isn't going to get us there. Go back to the start and we have to try again. So it's one of those where you just got to try something and see if it works. So you could try substituting in using the sine squared theta plus cos squared theta equals 1 identity. See how you can link that to the power of 4s. What I've spotted and what isn't very obvious is the numerator is a difference of 2 squares. If I just simplify it a little bit, say I had x squared minus 9, remember that can be written as this and that. That's the difference of 2 squares. If I had x squared minus y squared, be x plus y, x minus y. If I had x to the power of 4 minus y to the power of 4, it would be x squared plus y squared, and then x squared minus y squared. So I'm going to use this down here, but in terms of cos and sine. So it's going to be cos squared theta minus sine squared theta, and then cos squared theta plus sine squared theta over cos squared theta. Now here I can use the identity we're talking about. So I'll write it down at the side so we know where this has come from. Cos squared theta plus sine squared theta equals 1. So this whole thing equals 1, not the first bracket because there's a minus in the middle. So it's just 1 times by the other bracket. Now I'm still thinking about how I can get a tan squared theta. So again, if you want to try changing sine squared theta equal to 1 minus cos squared theta, you can do. I'm going to show you another trick that's common with proof, and that's just going back to fraction basics. So when I'm doing something like 5/8 minus 3/8, we actually skip a step. We would just go straight to 2/8 and simplify. But the step that you may have seen when you first learnt the method of taking fractions is by combining it into one fraction. So 5 minus 3 over 8, which is 2/8. If you look at this, this is similar to what I've got here. So what I can do is I can go back to the first step. So split up the fraction with the same denominator and the minus in between. So as I say, this is a common technique that you will see more and more. So I'm going to write it as cos squared theta over cos squared theta minus sine squared theta over cos squared theta. Why have I done that? Well, straight away I can see if I simplify those fractions, I'm going to get 1 minus tan squared theta. Cos squared theta divided by cos squared theta is 1. Tan squared theta is equal to sine squared theta over cos squared theta. So I've replaced that with tan squared theta. And then we get the right hand side. Okay, let's have a look at this one. So you could argue on these that both look complicated, they do. So it's not right or wrong which side you start with. Again, what I was saying before is you might start with one side, not get anywhere, and then think, right, I'll start on the other side, see if I can get somewhere. I'm still going to opt for the left hand side because I can see two fractions. I'm thinking if I can combine the fractions somehow, I can get the one fraction on the right. Right, so straight away I see a tan theta. So it's not going to be very nice, but I'm going to change the numerator to sine theta over cos theta. Now I can work with this a little bit. If I just write it over here, two ways we can think about this. That's the same as saying, right, sine theta over cos theta divided by cos theta. If I change that to cos theta over 1, I've got division of fractions. And in particular, the keep, flip, change technique. So if I keep the first fraction, flip the second fraction, change the sign to a multiply, that's the same as working out what I had in blue. Or the other option is, if I leave it as it was, if I times both sides, not both sides, the top and the bottom, the numerator and the denominator, by cos theta, because both have a cos theta that I'm trying to remove. Okay, so when I do this, I will get sine theta over cos squared theta. And when I do this one, I'll cancel the cos theta from the top, and I'll get a cos squared theta on the denominator. You can see how both ways has got me to the same answer. So it's up to you how you want to write that. Make sure you're making a note of either this step or this step, and watch out for that going forward. So I'm just going to go to the actual answer part because I don't want to put both in my work, and you decide which one you've understood the most. So it's 1 over sine theta plus sine theta over cos squared theta. I've sorted out that fraction in a fraction. Now I want to get to just one fraction, and I've got 2. So if we go back to a numerical example, 3/8 add a quarter. Remember, if I'm adding some fractions like that, I need a common denominator. So I'm going to have to do the same over here. And when I've got algebra, the common denominator, the easiest one to opt for, is just by multiplying the denominators you've got. Here, I could have opted for a denominator of 8 and just manipulated this fraction. But if this was something else, like 1/3, then the easiest way to get a common denominator would be to multiply the 8 and 3. So I'm going to do the same over here. So I'm going to write it as 2 fractions first of all. With a common denominator. I've just multiplied the denominators. Now I've times sine on the denominator by cos squared theta. So what I'm going to have to do is times the 1 by cos squared theta. On the second fraction, I've times a cos squared theta by sine theta. So I'm going to have to multiply the sine by a sine theta. Then I'm going to add the fractions now they've got the same denominator. And if you've spotted it, the numerator is an identity. So sine squared theta plus cos squared theta equals 1. So that is 1. So I'll be left with 1 over sine theta cos squared theta, which is what I wanted. So that equals the right hand side. Alright, some of those got very difficult. Proof is hard, it does take practice, lots and lots of practice. So these questions are in your lesson booklet. Please have a go at them. If you're wanting any help or to check answers, these have actually come from the textbook. So chapter 10 we're on. This is exercise 10C, and these questions are from question 5. So you can always be using the Active Learn textbook to look at the full work solutions and check how to do step by step by step. Alright everybody, that is the end of the video and the end of this chapter.